So section 1.1 is Introduction to Graphing. Objectives 1 and 2, plotting points and determining whether an ordered pair is a solution. We just did. I'm not too worried about it. So we're going to jump in here to find x and y intercepts. X-intercepts are when you have a horizontal location, but your y is 0. So you just let y equal 0 and you'll solve for x. Y-intercept's the exact opposite. If you want to find it, that means it has a y location. So we're going to let x equal 0 in order to find it. Okay? So on both of these, I left plenty of room, and hopefully you kind of do it as I do. I try to label what I'm finding, so I always find the x-intercept first. And I always hint to myself, what does that mean? Okay? So whenever I'm finding intercepts, I say, this is the one I'm locating right now, and this is how I'm going to do it. I'm going to put y in for 0. So it's exactly what we just got done doing in our prereq. We're going to solve equations, but we have one step before it. We got to knock out something by putting y 0 in for y. That's the only extra step we're going to be doing. So 2x is going to stay exactly as is, minus 4, and then what are we inputting for y? 0. So it was just that one extra step to knock out that chunk of our equation, right? Because we haven't done anything with 2x, but what's negative 4 times 0?
0.
0, and that's the whole idea. So now we're just left to x to solve. And doesn't that look like the equations we just got done solving? Okay? So since that's multiplication, how do you undo multiplication? Divide. So our x value is 4. What we want to be careful of is x-intercepts are presented to you in a variety of ways, but in my course, and I think most of the college algebra instructors here on campus, an x-intercept is an ordered pair. So when you say x equals 4, they will not accept it. They want it as an ordered pair. So what did we find? We found the x value, but what was the y value that we put in?
0.
0, okay? So kind of keep that in mind, guys. X equals 4 will not be accepted as an intercept. They're going to want that ordered pair there. And then we're just going to do the same thing for y-intercept. So the y-intercept, I just remind myself that I'm going to solve by making x 0. So I'm going to have 2 times 0 minus 4y equals 8. What happens to this chunk right here? Goes to 0. So we'll just have negative 4y equals 8. So I'm just going to divide both sides by what? You got it. The negative 4 over negative 4 cancels to leave you with y equals negative 2. But they're going to want that as an ordered pair. So what's the x value for this intercept? 0. And then we found that negative 2. So that's something like maybe on the worksheet you don't do that. I probably won't count off. I might just slap your hand a little bit and say, remember, it's an ordered pair. But my math lab will be looking for that, and by the time we get to the test, I'll be looking for an ordered pair as well. So you want to keep that in mind. Why are x-intercepts nice? Because if you guys, I think, has everybody taken an algebra course at some point? That you can use the x-intercepts and y-intercepts to graph the line, right? You can plot one, plot the other, connect them, you're done. There's your graph, all right? So the next objective is objective 4. It's finding the distance between 2 points in the plane and finding the midpoint. So if 2 points are exactly left and right of each other, it's easy to just count over. Or exactly up and down from each other, it's really easy to just count up. But if it's like catty corner, it's like, what is that distance? So here's the distance formula. Guys, this is actually derived from the Pythagorean theorem that we did yesterday. So notice we have 2 legs of a triangle, right? So a squared plus b squared equals c squared. But we want to get c isolated, so what do we have to do? We have to take the square root. So that's actually what we were doing, but generically. On here, notice they do have x2 first and y2 first. It honestly does not matter. Just whatever x you choose first, make sure its corresponding y is the first y you choose, okay? For example, on this problem here, we want to find the distance between 6, negative 1, and 9, 5. If I choose this x first and put 6 there, I must put his corresponding y, negative 1, there, okay? I usually just don't try to make it difficult. I was like, I'm just going to label this. This is x1, this is y1, this is x2, this is y2. And I just go with the formula. I mean, it's not too hard once you have everything labeled there. All right? So our distance formula is going to be d equals a huge square root. So this is why on Tuesday we did the order of operations. We need to remember the square root, guys, is the very last thing we're going to do. We're going to do the parentheses first, then we're going to square, then we're going to add, then we're going to square root. All right, let's put everything in. So we're first going to do x2, which is 9, minus x1, which is 6, the quantity squared, plus, since I chose 9 first, guys, his y of 5 must be first, minus, this is kind of awkward, negative 1 squared. So that's kind of weird because you have double parentheses, but I never like two signs butting up to each other, so I always put a negative in parentheses there. All right, so order of operations, what are we going to do? We're going to do the subtractions first, all right? So d is going to stay as d. The square root's going to stay as the square root. The squares are even going to stay squares, but what's 9 minus 6? 3. And this is just testing your integer skills. What's 5 minus a negative 1? 6, right? Do you guys remember that a minus and a negative becomes a plus? If not, guess what we have? Our calculators. All right, what's our next move that we're going to make?
We're going to add them together.
Not yet.
Oh, you have to
Square it, right? So remember, we're going to do the squaring first. So we're going to have d equals, keep the square there. What's 3 squared? 9. What's 6 squared? 36. Okay? And remember what we learned. I passed it back to that worksheet to you guys. The square root of 3 squared plus 6 squared is not equal to 3 plus 6, right? We need to do the math underneath first before we take the square root. What's the square root? What do we add up to? 45? Okay. So what we want to pay attention to is how MyMathLab asks for your answer. So they might ask for a reduced radical, and that's what we went over yesterday. Remember, a reduced radical means let's break him down and see who gets to come out. So who's going to be able to come out and play? The 3, right? So the 3 will come out to play. So 3 root 5 will be the exact answer. So if they say, give me the distance in exact using radical form, you know that's what they're looking for. But if they say, give me the distance rounded to the thousandth place, you know what they're looking for. So we can actually either put this or that in your calculator and get a decimal answer. So what do you guys get when you take the square root of 45 in your calculator? What'd you say? Big old decimal, right?
6.70.
Let's round to 3 decimals. So we have 70, and then what's this right here?
0.82.
Okay, 82, because the 2 will keep that at 8. Is that all right? So this is called the approximate. The approximate always makes sense to me. So say this was like a real life problem and we had like a triangular garden or something, and we had to find how much fencing to go from like one corner to the other. You tell your gardener, oh, get 3 root 5 feet of fencing. He's like, what? But if you say, get 6.708, you know, so decimals, those approximate answers always make more sense because that's what we're used to. We're not used to radicals. Are there any questions there? Okay. So that is the distance formula. It's coming from that Pythagorean theorem, okay? That's where it's derived from. If there's no questions, let's go ahead and flip it to the top of page 2, if you haven't done so already. So the next thing that sometimes we want to know is the midpoint. What is halfway between 2 points? So what we know, and again, that's easy if they're vertical from each other and horizontal from each other, but if they're catty corner, all they do, guys, the midpoint means the middle. So how do you find the middle of 2 numbers? You just average them. How do you find averages? Add them up and divide by how many you have, okay? How many points do we have? 2. So all we're going to do is average our x values. We'll add one x value to the other and divide by 2 to get the average of the x values. And then we'll add one y value to the other and divide by 2. Okay, so this is x1, y1, x2, y2. So our midpoint is a little bit different than your distance, because your distance is one value. It's how far things are from each other. Your midpoint is an actual point. So we're going to get a point, an ordered pair, an x value and a y value. So kind of keep that in mind. So I'm going to just use giant brackets. We're going to do 6 plus 9 over 2. And we're going to do negative 1 plus 5 over 2. And again, I don't think MyMathLab's super picky on this, but depending on how they want your answer, they'll either want it as a reduced fraction or a decimal, okay? So let's see, I don't even have my answer here. What do we have? So we have 15 over 2, and what is that, 4 over 2? So this is going to be 15 over 2 and 2 as your answer. But if you were to go and graph that, you're like, oh, what's 15 over 2? Just throw it in your calculator. It's 7.5. And that's what I always do. I always kind of just get like a rough estimate. So my math lab will say either a reduced fraction or a decimal. So you'll know what to leave it at. On my test, I'm not picky. Or if I am going to be picky, I'll have it in the instructions. Is that okay? You guys see what we did there? So we just took each of our x values, added them, and divided by 2. I don't have a whole lot of room, but if we were to graph this, 6, -1, and 9, 5, 7.5, 2 should be halfway between it. Have you guys seen the distance and midpoint formulas before? Okay. So the next thing I think is kind of like the most difficult part of section 1.1, so be sure to let me know if you have any questions. It's the equation and the graph of a circle. So we know y equals mx plus b is your equation to graph a line. Well, look at this crazy equation to graph a circle. All right, so we have a circle is the set of all points in a plane that are a fixed distance from your radius r from a center. So this is r, the radius. And your center is denoted h, k. So it has an x value and it has a y value. The equation of the circle is given by this. X minus h squared plus y minus k squared equals r squared. So there's a lot going on there. So let's see how to put this. The first time I do this with you, I'm going to do it using the formula. The second time, though, I'm going to kind of just tell you my shortcut, my tip of like, so you know what to do what. So when you come to your radius, this is h and this is k. All right? So we're just going to follow the rules. We're going to have this stays and this stays. All right? Just like when you have a line, y equals mx plus b. Y equals 3x plus 2. X and y are still in the equation. So when you do a circle, x and y are still in the equation. But you should be able to fill in the center as well as the radius. All right? So we're going to do what it says. We're going to keep x there, but then we're supposed to subtract h and square it. So that one's a little awkward because we have that negative again. Plus y, but we're supposed to subtract k, equals r 5/3, but we're supposed to square it. Is that okay so far? Just kind of plugging it in. Once you plug it in, they want you to always just clean it up. What do I mean? If you have this weirdness going on, negative plus or negative minus a negative, that's really what? Yep, x plus 1 squared. And then always, 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 you'll always have to square this. If you know, if it's an easy one, like 2 squared is 4, you can go right to it. I typically like to fill everything in and then have my last equation be my final. When it comes to squaring fractions, it's really easy. Just square the top, square the bottom. So what's 5 squared? 25. What's 3 squared? 9. There's your equation of a circle. What my hint to you guys is how do you put it in and plug in your h and k? The x and y parts, they should always equal 0. Okay? So like, what would make this inside 0? -1. And notice that's what our h was. What would make this inside 0? 4. And that's what that was. So I kind of go off it that way. So this one is even trickier though. So notice it has our center. So we have our h and our k. But it just says it passes through the point 1, 7. Okay? So that means we have this circle over here. And then it goes through 1, 7 over here. Because what do we need? We need the radius. But can't we find that radius? Don't we have a formula to find distance? So before we can jump into this equation, we're going to want this. This is a really creepy looking circle, but so draw yours a little bit better, okay? And before we can jump into this equation, we have the center, which we have, but we don't know the radius. But the radius is just always the distance from the center to any point on the circle, okay? So we're just going to use the distance formula to find our r. So r really equals d, which is, I'm going to write the generic so we remember, x2 minus x1 squared plus y2 minus y1 squared. I'm going to move that up so you guys can see it a little bit better. Oh, I went the wrong way. Let's go this way. There you go, okay? So the radius is really just the distance between these 2 points. Do we care which one's x1, x2? No, just label them. Let me make the radius x1, y1, because that just seems like your starting point, right? And then any point on the circle can be x2, y2, it doesn't matter. All right, so I'm going to plug it in. So our radius is going to be the point on the circle, 1 minus the point in the radius, 6, the quantity squared. And then go back and do it with my y's. The y on the circle, 7, minus the y on the center, -5. Is that okay? And you can be brave, guys, and you can flip-flop which point is what, but you'll see that we'll get to the same answer. R equals, let's clean this guy up. What's 1 minus 6? -5. But we can't forget that we have to square it, so really the negative doesn't make a difference, right? And that's what I'm talking about. 6 minus 1 is 5. 1 minus 6 is -5. But both of those squared get you 25. So that's why it doesn't matter which order you go. Over here, this is really 7 plus 5, right? So what does that add up to? 12. Is that okay if I just go right to 12, guys, instead of writing it as an addition problem? All right. Before we square root, we still need to square and add. So what is the square of -5? 25. What is the square of 12? You look at you guys, you know your 12 times tables. I like it. And then what's 25 plus 144? 169, which I would always throw into your square root first to see if it's a perfect square. Otherwise, you might have to do the reduced radical form, but it is a perfect square. What's the square root of 169? 13. So now we have our radius. So notice how much more work we had to do on that one. Here they flat out told us our radius. Here we found it by doing the distance formula, okay? So we have everything we need now. So I'm going to use this generic equation up here. X minus my h, which is 6, plus y minus my k, which is -5. Both of those quantities are squared, equals my radius, which we found, 13 squared. You guys see that? Okay, I never know if I'm like blocking or not. All right, x minus 6 squared is exactly how we want it. We're not going to change anything on there. X minus 6 squared. Y minus a -5 is really what?
Y plus 5.
You got it. And then this is kind of interesting. Look, we do all this work to find our distance to square root it to get 13. And then what do we turn around and do? Square it to go back to 169. Isn't that funny? But technically, that's what we're supposed to do. And you guys just found the equation of the circle. What does an equation of a circle mean? Oopsie, It means any point on this circle, when plugged into x and y, will make the left side equal 169, okay? And sometimes it's harder to find than, but it's easy to check. Like, so if they say, is this point on your circle, you would plug in the x and the y, do the math on the left to see if it equals that 169. So it's like what we did earlier today with checking solutions, but with both an x and a y. Are we okay? All right, so let's look at our last thing is how do we go about graphing it once we have an equation? So graphing a line, like I said, we have intercepts, so we can do x, y. On here, we want to start, this is where like, I will not be judgy about how pretty or ugly your circles are, but if you have like a compass at home and you want to bring it, feel free. First, we need our center, so we need to know where to start. Secondly, we need our radius, so we know how far to go out, and at that point, we kind of have to be almost artists a little bit to kind of get the curve to work. So this is where my little trick, I feel like, helps a little bit. So let's find our center, HK. My little hint to you when you already have the equation is ask yourself, what could you plug in for x to make that chunk 0? What could we plug into x to make this chunk 0? 1, right? Or what did we subtract? We subtracted 1. So that will always be h. What could we plug into this chunk to make this 0? -2. Or what did we subtract to make +2? -2. There's our center, guys. Let's go ahead and graph that. So we're going to go over 1, down 2. And oh my gosh, my circle, I'm really proud of my circle on here, on my answer key. So if it doesn't look good on here, I'm going to show you this one. So, all right, what is our radius, guys? Well, our radius isn't flat out given to us. What do we have to do? We have to take the square root of whatever that value is, right? Because they squared the radius to get 9, so we have to square root it to get our radius. So what is our radius? 3. All right, so what's the easiest way to do this? A circle, you can go in any direction, but don't you guys agree that it's easier to count left 3, right 3, up 3, down 3, like kind of north, south, east, west? Do your compass. Once you do that, then you're just going to try to connect those dots as best as possible with semicircles, right? So what I'm going to do is I'm going to go up 3, 1, 2, 3, plot that guy. Go down 3, 1, 2, 3. Go right 3, 1, 2, 3. And go over 3 to the left, 1, 2, 3. Okay? So this is where you, depending on how good you are, you kind of just want to draw like the best half circle that you can. And then do it again on the other side. So mine's a little creepy. This side, I'm going to do this quarter a little bit better. There's no judging. Oh, that's not too bad. Okay? What's interesting, guys, is that you have to have that center in order to graph it. But is the center actually on the graph of your circle?
No.
It's not, right?
I just messed up on. I went in.
Yeah. So that line, that actual circle that we drew is the graph of the circle. The center is actually not part of it. It's just what gets us started in order to find that circle, which is kind of interesting. So